And we are live. So, welcome to the first meeting of GDG for this year. Uh, so, let me get this going. So, you guys all know me. You can reach out to me on Google Plus or via email or whatever way you find convenience. Of course, we have our code of conduct, which can be summarized as be excellent to each other. You can find the full code of conduct at gdggigcity.com/coc. So affiliates and sponsors, of course, Code Journeyman donates the space that we meet at. And then, of course, there is ChodDev. And starting as of last month, we now have Manning Publications. So that's an awesome new avenue. And with that, you can use promo code UG367 and get 30% off all purchases at manning.com. And they do really good books on technology. So like Java or ASP, or even they have several books on Go or C. So just check it out. And I think it also applies to the early access. And we can actually get free copies of those for reviews. And all they ask is that we submit like Amazon reviews for it when it publishes. So, upcoming events. On my end, it looks like there's a delay. So this may be interesting.
Yeah, a little bit.
I guess I'll hit the button early. Anyways, starting next month, it's take 2 of the Android study jams. It's a new format of the class. It's aimed for people that are exactly beginners. So these are people new to either programming or just programming in Android. It's a 4-week long session, and there's the introductory hangouts on February 4th, and we can set up a viewing party for that. A couple of people that help put the class together will be there to basically answer questions and give a brief intro to what the course is. And so we don't have a topic scheduled for next month yet. If you have an idea, please let me know. But I did not change that, but it's supposed to be February 17th, not January 17th.
Okay.
So, announcements. As I said, Code Journeyman is moving offices. We're moving into the TARDIS basement at Signal Base. So it's 1028 Signal Mountain Road. So when you're going down Signal Mountain Boulevard, if you're heading towards Suck Creek, and that way you pass the Walmart and the BP and Shufords, there'll be a sharp left. We're on the building on the right of that. And we are talking about throwing an office warming party for when we move. So if that does happen, we will definitely let and put the word out. So hopefully see you guys there. And for this month's talk, it is on working with the time package and Go. So I'll go ahead and skip over this because you basically covered that. So working in time and Go. So as you may or may not know, Go has a import system, kind of like how Python and Java all works. So to do anything that involves time, you're going to need to import the time package. And a very basic usage would be to print out the current time. So So for that, you import the time package, and then you use the now function in it. So time.now, and that will print out the current time. So if we run this in here, the the time and date won't be right on this because this is using Google App Engine and they don't allow access to certain things on the system level, but this will still give an idea. So if we do the run, you'll see that it prints out the time here, which it thinks it's November 10th, 2009 at 11 o'clock in the evening, but that gave us the time. So one of the things that's common with working with time is having to parse in dates that you are given or format out dates to display. And doing this in Go differs from other C-like languages because it doesn't use tokens like %A or %B and that most languages use. Instead, they actually use a real date. So they use January 2nd, 2006 at 3:04 p.m. For those that are very familiar with these strt_f time tokens, there's actually a website called flippinggodateformat.com, and when you go there, it will basically convert those tokens into the Go equivalent. So you can give it in these tokens here, and it gives you that, which you can feed into your program. So working with these for formatting, so you can daisy chain. So here we're taking the now function that we used in the last example, and we're appending the format. So it's going to take the current time and format it, giving it using this pattern here, which is year, month, date, and then 12-hour time. So running that will produce a better looking result. So it still thinks we're in the past though. So only being able to display formats is half the battle. So actually parsing dates that you're given, you use the parse function in the time package, and you give it a format, which Go defines a handful of them already, and you can give it arbitrary ones as well using the January 2nd pattern. So here we're going to give it this time to parse. So today's date's at 6 o'clock, and we're going to have it print out two lines, the first line with the date and the second line with the current time. So running that will result in this. And using the underscore here, what that does is if it's only going to be a single digit, so if it's like the 1st through the 9th of the month, it's not going to have two digits there. It's just going to have just the one. So that's just a stylistic thing. So as I said, Go comes with a bunch of predefined formats, and you can see the full list by checking the constant section of the package documentation, which you can get just by running go doc and then time, or by going to their website and pulling it up. So here's the list of all the formats that they include. So when dealing with dates, the question of date time math is going to eventually come up, whether it be dealing with different time zones or actually having to do calculations to go forwards or backwards in time. So doing that is fairly easy in Go. So first of all, we'll have a look at working with time zones. So by default, when you tell it to print out or give you the current time or feed in a time or parse a time, it's going to use the UTC. So if you want it to actually parse with a given location, so for example, to have Eastern Standard Time, we tell it to load location saying American New York for the EST, and then we'll define our format. So here we're going to say January 2nd, 2006 at 3:04 p.m., and then it's going to have the time zone in parentheses. And so instead of calling parse, we're going to call parse in location, and we give it our format that we're going to use, the date string that we want it to parse, and that time zone that we want it to be in. And with this, and so then we're going to print out that time in that time zone. Now another thing you can do is you can take that and you can have it display the time in a current time zone. So here we're going to convert it to the CET, which is the time zone currently in Berlin, and we're going to print that out as well. So if we run this, we'll see that we have January 20th at 6 o'clock here in Eastern Time, but it's actually January 21st at midnight in Berlin. So say we wanted to go the other way around. We were given a time in a different time zone, and we want to convert it into our local time. Well, you can do the same thing to an extent, but instead of using the in function, you just use .local. So here we're giving it the time zone of Berlin for CET. We're defining our format the same way we did in the last one. We still use the parse and location the same way. And we're going to print out the time that it gets after parsing that. And then we're going to convert it into the local time zone, which in this case is just going to be UTC. But running it, we should notice that there is an hour difference between the two. And there is. So that's the basics of working with time zones, but for adding and subtracting dates, there's three main methods for doing that in Go. There's the add method, which works on a duration or an offset. There's an add date, which works on years, months, or days. And then there's the subtract method, which will subtract two dates from each other and give you the difference between them. So the add method, it takes in a single string and returns the time after applying the time duration offset. The duration is a string that can be signed, and it can have a unit suffix. Valid suffixes is ns for nanoseconds, us for microseconds, ms for milliseconds, s for seconds, m for minutes, h for hours. So an example would be 300 milliseconds, or minus an hour and a half, or 2 hours and 45 minutes. And for example, in those in action, we're going to get the current time, and we'll display that using the println, and then we're going to use the parse duration to giving it the 1h for an hour. So that's going to return us an hour offset. And we're going to take our time and add that in. So that's going to return time an hour ahead. And then we're going to subtract an hour and 30 minutes using the same parse duration and the add method as well. So running that, so our first one is the November 10th at 11 o'clock. And then once we add in an hour, it'll be November 11th at midnight. And then our last one, we subtracted an hour and 30 minutes, so it's November 10th at 10:30. So to do it at the day level instead of the time level, you use the add date method. This takes in 3 arguments for years, months, and days. And like the durations, it can be positive or negative if you want to go back. So if you want to go back, say 2 years, you would pass in a -2 for the year argument. And this method also normalizes the results to correct for the fact that different months have different number of days. So like some months have 28 days, some have 30, some have 31. It will correct for that so it won't have weird offsets. So an example, so we use our time.now function to get the current time, and then we'll print that, and then we're going to add in a month, and then display that. So here, our first one is the November 10th at midnight, or 11 o'clock. And then the second one, after adding the month, it's now December 10th. All right, I think I just lost the recording. Are you guys still there?
Yeah, I am. And mine still says live. So. Still says live.
Okay, well, the Chrome crashed on the desktop again, so I don't know.
No.
I wonder why it is doing that. All right, let me see, because I can edit this out if it still is running. Let me just pull it back up just in case. I think this computer just needs rebooted. So while we're at this, any questions or anything?
Not so far. It's pretty cool. There is a pretty good lag sometimes. Sometimes you're talking about the code and it's still on the introduction slide to that section.
Yeah. Let's see. Let me pull this up. I think the YouTube would be a good test to see if I'm still recording. Oh, hey. No, I can't tell. Oh well, I'll just go with it. If it's recording, it's recording. If not, it's not. All right. So subtracting two dates. So if you have two dates that you want to subtract from each other to calculate the difference, which what you do is you use the sub method. And so in this example, you see the slides, right?
I just have black. I'm not sure.
You guys, okay. Um, crap, that's.
I'm seeing it.
You see the slides?
That's weird. I just have black. Huh.
Oh, now it went black.
Okay. Um, yeah, I don't know because I can't restart the recording now.
Now it's back for me. I see the subtracting two date slide.
Okay,
Yeah, it's back.
that's just odd. Let me do this. Okay, you guys still seeing things?
Mm-hmm.
Yeah, I am subtracting two dates.
Okay. It looks like I was able to pop my desktop back into everything, so we'll go with that. Okay, so in this example, we create a variable t1, which has the current time, and then we'll parse in a second time, which is 2 days in advance, so January 22nd, 2006. And that's in T2. And so we're going to subtract what's in T1 from T2 and get the difference between the two.
Hey, can I ask a question?
Yes.
What's that syntax where it's T2 comma underscore?
Okay, so time.parse returns two variables. The first one is of type time, which is our time object, and the second thing it returns is actually an error. And so when you use the underscore, you're telling the Go to ignore whatever would be here. So I'm telling it to ignore the error.
Got it. Thanks.
Very bad practice, but when you're doing examples, it works because you don't need a bunch of if error equals nil in example code. So I'm just throwing away the error in this case if there is any. So I can show an example of what that would look like if I wasn't discarding that here in a second.
No, I understand now. I just didn't understand. Yeah, I got it. Thanks.
Okay. So if we do this, so this is actually going to have an interesting result because remember this thinks it's in 2009 and we're giving it a date 2016. But if we run this, it returns a difference of 54,313 hours. So if we give it a more normalized, let's see here, 2009, 11, I'll say 11. Should be a day. Okay, an hour because midnight. But yeah, so that took what was in T2 or T1 and subtracted it from T2 and found that there was an hour difference. So another thing that's fairly common is working with Unix timestamps or seconds since epoch. Go's time package has first level support for these, and there's it does it with the Unix function, which can take in Unix timestamps and parses or returns back the valid human time, as well as a Unix and Unix Nano to get seconds since epoch and nanoseconds since epoch. So, and the delay is back, I can see.
Yeah, I still see the 2 date slide. Subtracting 2 dates.
Yeah. We'll give it a second to catch up here, I guess. It looks like it started to draw one.
Yeah, it dimmed out. I see epoch now, but it's dimmed. It's not, fully.
Hmm. Okay. Do you guys still see anything?
Still see the kind of grayed out epoch slide.
Let me try redoing this share then. Oh,
Now it's Go plus Unix timestamps.
there we go. That was the first slide you were supposed to see.
Oh, okay.
So yeah, so this Unix function here, the first item on the list, that's what takes in the Unix time. It will give you back human time, and then the 2 methods, the Unix and Unix Nano, will take human time and convert it to the epoch or seconds since epoch. So working with the epoch, so if you want to take the current time and convert it to Unix timestamp, the way you can do that is do time.now and then .unix for seconds or .unix nano for nanoseconds. So if we were to run this, we'll have 2 outputs. So this first one is seconds since January 1st, 1969, and the second one is nanoseconds since then.
So that seems strange that the nanoseconds had so many trailing zeros.
Well, it's because they don't. That's a app engine thing. They're not allowing it access to the system to actually calculate the true time.
Oh, that's right. I forgot that. Yep.
They're actually
zero,
faking
zero,
that.
zero for the time. Yep, I remember now. Yep.
So if I were to take this and actually run it locally, you'll get proper results. Let me do that real quick.
You must be on your Chromebook.
Yep.
Yeah.
If my desktop was working right, I would have been on there. typing in German and speaking in English does not work. So we'll paste this in.
We might be stuck again because I see your cross shell.
Yeah.
SU, I don't see anything else.
That's good because you don't need to see my failures on password entry. I'll wait till it catches up. It looks like it kind of has. So you should. The last command should have been a go fmt, right?
Yep.
All right. So if we were to run that, oh there. That's the actual.
Yep, that looks more legit.
Yeah.
Yep.
Yeah, it's just an app engine thing. So one thing that is missing that's fairly common is milliseconds. So to do that, there's a little bit of math that's actually involved.
You got to figure it out from the nanoseconds, right?
Yeah, so you basically take the nanoseconds and divide by a million. And if the slides were to update, you can see what would be involved. I'm not sure what their reasoning was for not supplying a Unix milli, but it's not that big of a deal when you know how to do it. Yeah, there we go. So you can see it here. So you just take the Unix nano and then divide by a million, and you'll get the phony results. But I wonder if it's the Chromebook doing it. Like, it's not seeing a big enough difference to bother redrawing.
That's interesting. Maybe.
Because I just switched tabs and then it's there now. Interesting. But yeah, that's how you get milliseconds since epoch. So that's going from human time to Unix time, but to go the other way from Unix time to human time, that's where the Unix function actually comes in. So here we're going to take seconds since epoch and nanoseconds since epoch, and we're going to both convert them into human time. So the Unix function takes two arguments. The first one's seconds, the second one is nanoseconds, and you only need to populate one. So this first line is going to print out the time based off of the seconds, and the second println is going to do it based off nanoseconds. And they will match, but since it's faked. But if this was really done on a computer, there may be a bit of a skew since the nanoseconds would be different. So some of the more interesting things. So Go has a concept called timers, and these allow for execution of code at some point in the future or at some interval. So to define a timers can operate in a blocking manner, such as the example below. But at this point, you probably want to use time.sleep instead. But the way it works is we define a new timer, giving it a duration. So this, in this case, we're going to say 2 seconds. And then this timer.c line just below that, what that's doing is, since the new timer creates a channel, we're going to read from that channel and wait till something comes in. And so that's how the timer notifies us that the timer is expired. So here we're going to create the timer, we're going to wait until it sends us something, and then we're going to act on it. So an example of that, it's going to run, it's going to wait, and it should have already displayed. Let me do this. Yeah, there. It displays the timer's expired. So that's not all that useful, but you can do it in a non-blocking manner, taking advantage of Go's concurrent nature. There we go. So to do that, we use Go routines. So we still create our timer the same way, still for 2 seconds, but we're going to create a Go routine that's going to listen on that timer, and when that timer's up, it's going to print out a message. But we also have in the parent here, this timer.stop. And what's going to happen is once that's called, it's going to stop the related timer. So it's just going to stop it even if it hasn't expired. And then if it did stop it, we print out this message. So out of curiosity, what messages do you think this will display?
I'm going to guess timer stopped. Oh,
Yep.
no. Dang, I was wrong. Oh, no, it's right. Yeah. I thought I saw exited. It didn't get quite drawn in, and I thought that was expired. So, yeah, okay, cool.
Yeah, so basically why that happened is because this is running off in its own Go routine, which basically works kind of like a thread. So this is off doing its own thing. It's waiting for 2 seconds. Well, this wasn't waiting, and so this immediately, the timer.stop, that wasn't waiting, so that immediately got called, so it stopped the timer before it could expire. So if we wanted to make this timer actually work, we can simulate the fact that our parent here is doing work. I'm making it sleep for, we'll say 3 seconds. All right, so we put in a sleep for 3 seconds and ran it, and so now the timer actually fired before the stop function could get called, and so the timer did its thing, and because we never actually manually stopped the timer stopped message never got displayed. So unlike timers, there's also, which are good for one-offs, there's a thing called tickers, which are used for something that's going to repeatedly happen at a regular interval. So the way those work is fairly close to timers. You'll still use call new ticker. It still takes in a time. And so in this case, we're going to set up a ticker for 500 milliseconds. And then in a go routine, we're going to use a for loop to read from the channel that gets created. So every 500 milliseconds, this ticker is actually going to give us a timestamp of when the ticker ticked, and so then we can display it. And so we're going to let that run for a couple loops because we're going to sleep for 2,000 milliseconds, and then we're going to stop the ticker and go on. So if we run this, yeah, so we see that there's a ticked at and then a timestamp 3 times, and then we stop the ticker. If it wasn't for the fact that we had line 17 in here, that ticker would have just kept on going until the program actually came to a stop. So another thing that's common if working with remote systems like a database or making remote calls like HTTP calls or anything like that, or just doing any kind of work where you want to make sure it doesn't run forever in case something happens, you can implement a timeout and go very easily and elegantly. So with that, there's a little bit more work involved. We don't have a helper method that gives us a pre-made channel. So we actually need to make our own channel. So we make a channel that's going to hold one item that's a string, and then we're going to use a go routine that's going to simulate work. So we're going to sleep for 2 seconds, and then it's going to feed in a result into our channel saying that, hey, it's returned something. So the way the timeout actually works, we create a case switch, and we set up 2 cases. The first one is going to read from the channel, and if it gets something back, it's going to act on it. In our case, we're just going to print out the result that came back. And then we set up a second case that's going to wait for a second. And if that fires, then it's going to do its actions, or in this case, print out timeout 1. So basically what you do is you create a race between these 2 cases. Whichever one is true first is the one that gets acted on. So if C1 has something that can be read, then our println res is fired. Otherwise, if our time after call it triggers, then we do that. So let's come over to here real quick. Actually, let me go to the second case. So the second case here, we create a second channel. We're going to do the exact same thing, except we're upping the time in our second case down here. So instead of giving it a 1 second before timeout, we're giving it a 3 seconds before timeout. And so that way we can see both results when we run this. And where's the result? Yep. So again, in our first case, we had 1 second before the timeout happens, which is why the timeout was triggered. The second case, we had 3 seconds, which is why the result actually worked this time. And that's concludes basically the basics of working with the time function. So just go ahead and open it up for any questions or comments or anything that anyone may have.
That was good. Hey, I wanted to mention, and I didn't before you got past it. I was reading something the other day, and I got a chuckle out of it when you were talking about Unix time and the epoch time. The
Yeah.
fact that, 2038 is going to be, when all that runs out, and who knows what'll happen between now and then. But I saw a reference to there's that date, that 2038 date's being called the epocalypse.
Yeah. Well, Windows already had theirs. That's what Y2K was. That was the Windows apocalypse because they made the stupid decision of doing the years in 2 digits.
And that was a big mainframe thing too.
Yeah.
We're really dealing with the mainframe stuff. Yeah.
But in the Unix world, they've made the choice of making the dates 32-bit integers, which is why time's done in seconds. And that's why the 2030 is the Unix apocalypse, because that's when we will hit the 32 cap. But a lot of systems already moved over to using 64-bit integers.
Yeah.
So it won't be as big of a deal as Y2K was, but yeah, it is still a bit of a concern.
Right. I just thought it was funny that they coined it the epocalypse. I thought that was pretty good.
Very much better name than Y2K. And also, don't forget to do surveys. Even if you did it in the past, do one again, because they do recurrently look at them, and it does help our chapter out. It helps Google actually give more funding to the Google Developer Program for different events. And you can also win either an Android Wear device or a tablet or a Chromebook, whichever one you choose.
So will you put like the link to the survey in the meetup or something?
Yeah, I'll post the link there because it should be on screen, but it's not getting drawn on screen. Let me see if this forces it to draw. Yeah, there. But I'll, of course, post this into the meetup and all that. So, and with that, let's see. Thank you, guys.